Okay, so looking at our two graphs here, we are looking for whether the graph is continuous, aka there are no holes or jumps. Your pencil does not get picked up when you graph and things of that nature. So if we're looking here at this one, yesterday we had talked about what type of a discontinuity this was. And what type of a discontinuity is it? It is a point discontinuity. Okay? The reason we can tell it's a point discontinuity is if we follow the graph towards that value, right? So if we go towards it, right, what does the y value go towards? Right, that's going to be looking like a y value of 5. Okay, so as the graph approaches, I guess our point in question is -5 down here, right? This is, nope, -4. That's where your hole happens to be at -4, an x value of -4. So as the graph approaches -4 from the left, the y value approaches 5. And as the graph approaches that x value from the right, notice that they both approach the same y value. Okay, so if the graph approaches from the left and from the right, goes to the same y value, but there is an open hole there, that means we have a point discontinuity. Okay, so there are three things that we're looking for when we're looking for point discontinuity. What is the graph doing from the left side of that x value? What is the graph doing from the right side of that x value? And what is the graph doing exactly at that x value? Okay, so if we have point discontinuity, we're looking at three different things. Whoops. But over here, notice what type of discontinuity is in this picture. This one is called a jump discontinuity. Right? There is a big gap, or I guess it's not a big gap, but there can be a big gap in between your two y values here. So that gives us a jump discontinuity. Now, what do you notice about the y value as we approach -1 from the left? What y value is that graph approaching? Right, +2. So from the left, our graph is approaching +2. But from the right side, if I approach -1, what y value is my graph approaching there? Right, +1. So for a jump continuity, the left side and the right side go to different values of y. Okay, they don't go to the same thing. So that's how we're going to show that something has a jump discontinuity. Okay, so we either have point discontinuity or we have jump discontinuity. So what can we say about a function if it is continuous at some, right, a value, right, x equals a, so that's some numerical value of x that is, of course, unspecified. So let's draw that. Let's do a little xy on here. Here's your little y-axis, and there's your x-axis. Okay, we're going to call this point some random point A, right, so we have the point A. So if our graph is continuous at some point A, let's see what actually is happening at that point. Okay, so three things are happening. Number one, as x goes towards from the left equals the y value from the right, and that x value is actually there. Okay, so we're looking for three things. Number one, and let's see about the notation that we write. So we write that as x approaches a, okay, so as the x values are moving towards that specific x value called a, we're going to put a little superscript as a minus. Okay, we put a little superscript minus. That means from the left. So we put a minus up there as a superscript. So as x approaches a from the left side, the y value is going to, I don't know, let's call it, what letter should we use? What's your favorite letter? C? C. So we're going to say that y value is called C. So as x approaches a, the y value is going to be at c. Okay, that's the first thing that's true about this graph. Number two, okay, as x approaches a from the right side, so from the right side we put a little plus up here. Okay, and that plus represents coming towards that point from the right side. Okay, so like the purple line, we're approaching from the right. So you're going this way, trying to converge, right? They're trying to see what that y value is. Where do they both converge? Okay, if you go at it from the right side, the y value also is the same, right? So those two y values are the same. And then the third thing we have to show is that exactly at that y value, you get, or sorry, exactly at this x value. In other words, it is not undefined or it does not exist. Okay, you have to actually have a y value at that particular x value in order for the graph to be continuous. Okay, it's not an open circle, it's a closed circle. Three things if you want your graph to be continuous at some random x point. Okay, so how do we write our jump discontinuity? Let's draw a picture of our jump discontinuity. Okay, so we can get a visual of what's going on here. Once again, we have our random x coordinate we're calling a. So for a jump discontinuity, the left side and the right side have different y values. So we'll say that that y value is b and this y value is c. Okay, so once again we're looking as x approaches a, right? So we're coming towards our graph like this. As x approaches a from the left, our y value is, in this case, we're calling it b. Okay, so as x approaches a from the left, as we're moving, along our graph towards that x value, the y values are going to something, right? There's always going to be a y value there. Okay, conversely, as x approaches a from the right, right, as we're coming at it in this direction, the y value is something else. Okay, so if f of a from the left does not equal f of a from the right, f of a from the left does not equal f of a from the right, then we have ourselves a jump discontinuity. And our last one, what if we have a point discontinuity? So we graph that, the point discontinuity. Once again, we have some value we're calling a, and we're going to have an open circle at that a value. Okay, so how does that look different? Well, the x approaches a from the left equals the x approaching a from the right. So we're going towards that same y value. So the y value from the left equals the y value from the right. But the actual y value is undefined or does not exist. Okay? So the two graphs are approaching the same number, but that point doesn't actually exist. There is no specific y value at that x value of a. Okay? So this is the mathematics, right? The notation, what we need to become familiar with, and what we're going to do in order to prove or explain what we mean in our practice problems. Okay, so let's look at some practice problems. So the first part says, determine the values which the graph could be discontinuous, right? Do we have a graph for these things? Right? No. Do you want to graph these things? Right? Probably not. So we're going to do this algebraically, right? Because sometimes graphing is hard and sometimes algebra is hard, but we're going to do it algebraically. So the number in question is negative 1. We are looking at -1 for our potential discontinuity. Okay, so we need to figure out what is happening at -1. So as x approaches -1 from the left. So which of our two graphs, the top one or the bottom one, is on the left side of -1? So we're going to plug it into, that's the wrong thing, we're going to plug it into this. We're going to plug -1 into this equation, and we're going to evaluate it and see what that y value is going to be. So I get a y value of -6. So on the left side of my graph, the y value is approaching -6. Right? That's the y value the graph is approaching. Okay, now what about on -1 from the right side? So which of our equations is on the right side of -1? That would be the bottom equation. So I'm going to plug -1 into that bottom equation, and I'm going to evaluate it and see what number I get. When I evaluate into that absolute value function, I also get -6 as my answer. Okay, so we can do some evaluating, right? Let's put this together. We have the y value of -1 from the left equals the y value at -1 from the right. Okay, so pretty good, right? But now, what about exactly at -1? So the left side goes to -6, the right side goes to -6. What's happening exactly at -1? Is there anywhere for me to plug in -1? Right, it can't go here because it says greater than. It can't go there because that says less than. So is there a place for -1 to exist? The answer is no. So f of -1 is undefined. So if we have the left side equaling the right side, but our at is undefined, what can we say about our discontinuity? That there is a point discontinuity. Okay, so that's our analysis. You find the left side y value, you find the right side y value, and then you find the middle y value, and you evaluate, right? We analyze and we get point discontinuity. Okay, so let's do the same thing for number 2. Right, we're going to check out, it looks like an x value of -1 again. So left side, right side, at -1, and let's see what happens. Okay, so when we evaluate from the left side, we get -2 as the y value. When we evaluate from the right side, we get -2 as the y value. And then when we look exactly at -1, since our thing says greater than or equal to, then the y value is also -2. So we have left side equals right side, and the point exists. So what type of discontinuity do we have? None, right? We are not discontinuous at all. Our graph is in fact continuous at that point. Okay, so remember what it means to be continuous. The left side and the right side equal each other, and the middle side is equal also, right? All three of those things happen if your graph is continuous. We have all three of those things happening on number 2, so our graph is in fact continuous. Okay, so yes, not very exciting, but it's good math. Okay, number 3, let's take a look, see at number 3. How many places are we checking out this time? Well, 2 places. So we're looking at +3, right? That one's shared by both of these. And also +5. So we're trying to find continuity at 2 different points. At x equals 3, and then again at x equals 5. Okay, so we're going to do our x equals 3 stuff. So approaches from the left, approaches from the right, see what they do. And then we're going to also do x approaches 5 over here from the left, from the right, and see what they do so that we can perform our analysis on these things. So here's our work, our evaluation of the left side. So at 3 we notice that the left side and the right side and the middle are all equal to 3. So what that means is that our graph is continuous at x equals 3. Okay? The left side equals the right side equals the middle. So that means it's continuous. But for at x equal to 5, the left side is 15. The right side is positive 4. So from the left, we're going to 15. From the right, we're going to positive 4. So at f of 5 from the left does not equal the y value at 5 from the right. So this is going to be a jump discontinuity at x equals 5. So let's look at our truly advanced problem. Okay, so notice here we have an equation with two variables, a and b. Okay, so we're really going to have to do some pretty serious mathematics to figure out what's going on, to show that we have point discontinuity. Okay, so what does it mean to have point discontinuity? So let's go over here and try to make that happen algebraically. Okay, so first let's deal with the -3. Okay, so this is the graph on the left side of -3, and this is the graph on the right side of -3. Okay, so we're looking at 2 times -3 plus 3. Right, so that's the y value on the left, and that needs to be equal to a times -3 plus 3b. So remember what it means. You plug in -3 in for your x. So -3 goes into the x on your top equation, -3 goes into the x on your bottom equation. Okay? We want the y values to be equal, so we evaluate on the left and we evaluate on the right, and we get, let's see, -6 plus 3 is -3 needs to equal -3a plus 3b. Okay, so we're kind of stuck here because there's nothing we can solve. We have 2 variables but 1 equation. Okay, so we're just going to let this sit here for a minute while we go on and look at +2, right? And maybe that can help us solve something over here in the future. So once again, now if we're looking at +2, this is now the left equation, and our bottom one is the right equation. So remember, we need to have equal y values. So we want a times 2 plus 3b, right? When we replace x with 2, that needs to equal 1/2 of 2 squared plus 3 times 2 minus 1. Okay, so you plug in 2 into your top equation, rather middle equation, right? ax plus 3b, so a times 2 plus 3b. And that needs to equal what happens when you plug 2 into the bottom equation. So let's math this out. 2a plus 3b equals, we do 2 squared. What is 2 squared?
4.
That's +4. So what's half of 4? Half of 4 is 2. 2 plus 3 times 2 is 6. 2 times 6, or rather, 2 plus 6 is 8. 8 minus 1 is 7. So I have 2 equations with 2 unknowns. So we're going to solve this by making a system of equations. Okay, so this is a throwback to Algebra 2. We're going to make -3a plus 3b equals -3. Right? That's one of our equations. And 2a plus 3b equals 7. That's our other equation. So we've just made a system of equations, 2 variables with 2 equations. we're going to solve this system. And it looks like we can solve this pretty nicely with elimination. Okay, I'm noticing that my b values here, my b variables, have the same coefficient. So what would happen if I were to subtract the bottom equation from the top equation? Right? This is one way that we can solve a system of equations, is by elimination. The other method is substitution. So let's subtract. What is negative 3a minus 2a? Negative 5a. What is 3b minus 3b? Right, 0. We have eliminated the b from our equation. And what is negative 3 minus 7? Negative 10. Okay, so with this solving my system of equations, which you haven't done for a while, I'll understand. Right, Algebra 2 was a couple of years ago for most of you. You get an a value of 2. Are we done? No, we also need to find the b value. So how are we going to find the b value? By plugging a back into either one of your two equations, whichever one is your favorite, you plug 2 back in for the a. So let's just do this one. So 2 times 2 plus 3b needs to equal 7. 2 times 2 is 4. 4 plus, so I'm going to subtract 4 from both sides. 3b equals 3. Divide both sides by 3, and b equals 1. So if our a value were 2 and your b value were 1, then we would have point discontinuities at both negative 3 and at positive 2. Right? That's a pretty serious math problem right there. It's got our current stuff about discontinuities, right? You need to know that the y values have to be equal. And then you get two equations with two variables, and you have to solve a system. Okay? That is truly an advanced question. Hopefully your brain is up to it. All right, y'all. Have a great weekend.